Assalamu alaikum, dear students. Today our topic is about sanitary landfills, and we will be focusing on the designing aspects and the layout of the landfills and what are different kinds of landfills which are being practiced. So, starting with our basics, some of the basics. So, what is the normal methods used for the waste disposal? So waste solid waste is a continuous source which is being added up in our environment, and it has many sources. It is coming from industries, it is coming from commercial areas, it is coming from municipal sources, it is coming from domestic sources, and all these wastes have different characteristics. Some of them are hazardous, some of them are non-hazardous. They need to be treated differently. So normally the disposal methods are different. We are also sometimes recycling the waste. We are sometimes reusing the waste. Sometimes we are reducing the volume of the waste. Uh, so there are different purposes of the waste which are further carried out once the waste is collected at some disposal facility. And uh, and the type of waste which is not able to be further uh, transformed into any kind of facility or any kind of form, that waste must be disposed properly in some landfill. So that landfill is, initially it was called a dump site, but now we are using engineered landfills. And what actually defines an engineered landfill? It is that kind of sanitary landfill in which we have a very controlled environment, and we are not allowing any kind of environmental degradation which is hazardous for the residents of the nearby vicinity. So normally the waste which is coming from different sources, it is either recycled, reduced or reused. And what are the possibilities if we are finally disposing it? We have the possibility of dump sites, and those dump sites are actually um uh, not properly controlled, and in that case it is quite prone to health risk for the residents. So that's why it is important that we should have a proper engineered and controlled landfill. And that's why uh, we will further check out what are the characteristics of a sanitary landfill and what an engineered landfill is all about. So first of all, we have the option of sanitary landfill, and second option is to reclaim the sea surface for the waste disposal landfill site. This is a very common practice nowadays in most of the mega cities of the world. We are experiencing that the landfills are not being established within the cities, but they have been shifted to the open areas near the seashores of the coastal belt, where there is comparatively less deep sea level, and it is easier to fill that portion of sea, and then that portion of sea is normally used for different purposes. For example, in Tokyo, that landfill has been developed in the sea, and once it's closed, then there is a runway and airport over that landfill, which is uh, used for international flights, and it's very a mega project of that city. So it is not only helping in proper utilization of the land, but also it is keeping a conservation of the and reclamation of the land from the sea, uh, 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 from sea area as well. So, what are the landfilling processes normally? The landfill are physical facilities used for the disposal of residual solid waste in the surface soils of Earth. Sanitary landfill is an engineered facility for the disposal of municipal solid waste designed and operated to minimize public health and environmental impacts. Then, what is the process? It is landfilling is the process by which a residual solid waste is placed in a landfill. It includes monitoring of the incoming waste stream. We will be monitoring what kind of waste is being disposed, and what kind of reactions are possibly going to take place. And secondly, the placement and compaction of the waste. It is a physical activity. Again, it needs to be properly designed, and then installation of landfill environmental monitoring and control facilities. So this is an important uh, component of engineered landfill, because we must monitor what kind of activities are being taking place in the landfills, because the chemical reactions will continuously take place, because the waste is going to react in one way or the other. It is going to either it is going to leach wastewater, or it is going to have some chemical reaction and releasing some gases. In both cases it must be monitored, and the amount of gases being released must be measured, and it must be controlled, and again the wastewater collected from the leachate is going to be treated. It is pumped back to the surface, and it is treated by different wastewater treatment techniques. So here is the planning of landfill, and for this purpose, methods for final disposal of solid waste. It's very obvious. Dumping on the land uh, is either by open dumping or engineered landfill dumping, dumping on the surface water. Um so earlier the waste solid waste was normally dumped and into the drains and rivers, and finally it was carried to the sea, but now it is banned. Mixing into the soil as a soil conditioner, it is only for the degradable waste, like domestic waste coming from the biomass, which is not having uh, the non-degradable component. Then reduction of waste is an important component, because the waste must be reduced. If if the solid waste being disposed is kept as it is not possible to handle such a huge quantity of waste. So the waste must be reduced, and this reduction has some of the processes. First of all, it needs to be shredded, it need to be incinerated. Incineration is one of the options for the burnable material, and especially the hazardous toxic waste coming from the hospital must be burnt to avoid its risk for the human life. So, engineered landfill, sanitary landfill was developed as a relatively inexpensive alternative to incineration, especially communities with sufficiently large areas. But usually, what happens, incineration and landfilling is carried side by side. Both are operated in parallel. And what benefit we are going to get is, first of all, by incineration we are reducing the amount of waste produced. By incineration we are expecting a reduction uh, uh, a huge reduction, and the leftover volume should be about 10% of the total waste. So this 10% volume is much easier to be disposed in the landfill. Now there is no other option left for that uh, incinerated waste, which will be called ash, residual ash, and that ash has nothing to be further done. So that the option left is the um, uh, disposal in the landfills. So first of all, one option is the landfill dumping placement. Second option is to use it for the non-bearable uh, construction material. It is also one of the options for the uh, residual ash, because it is going to have a high level of um, bearing capacity, and it has comparatively high compressive strength. So that's why it is very much useful to be used as a construction material, particularly at the places where much heavier loads are not expected. For example, in parks or in landscaping. So such things are easily done. Now we move forward to the landfill planning and designing and its operation. So major components, principal elements of the landfill planning, design and operation is landfill layout and design, landfill operations and management, reactions occurring in landfill, management of landfill gases, management of leachate, environmental monitoring, landfill closure and post closure care. These are the things, these are the components which must be taken care, and these are the processes which are actually comprising of all the landfill planning and its management, and also about the operations carried out at the landfill. Now these are explained by this graphical explanation sketch. This sketch is going to explain all the phenomena as described earlier regarding the different operations carried out at the landfill. So starting with the landfill design, this is the first thing to be done. uh, so first of all comes the site planning. Then there should be a drainage facility, there should be gas collection system designing, there should be a liner designing, then there should be a final cover design. These are the design aspects which are required at the landfill facility. Then we are also concerned with the placement, that is about the landfill operation. So it is about the cell, and it is about the placement of the waste. So we need to have a measurement about the load which is to be shifted in these different cells in which the waste is to be placed. So load measurement and the weight which is going to be incorporated, and then its routing is also important, how it will be carried and shifted to the um landfill. And then finally we are heading towards the placement, and then there are some reactions taking place. For example, reactions occurring in landfill are mostly concerned with the wastewater, which is created, which is originating from the chemical reactions taking place. So this is called leachate. So leachate management is another important aspect of the landfill planning, and it normally has two parts. First of all is the leachate collection and its drainage, and then leachate treatment, because this leachate is toxic and carrying hazardous chemicals, so it must be treated. So for treatment we need to collect it, and for after collection it is brought to the surface and pumped to the surface, and then there it is treated by using the most appropriate methodology. And then there is another point to be monitored, that is about the landfill gas management. This is about the gases emitted from the chemical reactions. These chemical reactions are supposed to take place due to the presence and of the different natured chemicals. Those chemicals will react together, they will produce gases, and those gases will be emitted, and there should be a way out to carry those gases to the surface, and it must be brought into some useful activity, and that is the conversion of gas to the electricity. So a gas flaring is also an important point, which is an indication of the activity being taking place and its intensity as well. Then we have another important thing, that is about the environmental monitoring. We are concerned about the soil contamination due to the leachate, and we are also concerned about the groundwater contamination due to that leachate. Then we are also concerned about the gas being evolved, gas being released. So we must have a monitoring system. There must be monitoring wells, there must be a gas well to monitor the gas situation. So continuously monitoring is important for a engineered landfill. So environmental monitoring is an important aspect. Finally, after all these activities, we will move forward to the landfill closure. Again, it is an important aspect. There must be a proper closing, there must be a proper design of the cover, because we are not uh, going to use it for any further activity, so it must be closed, and once it's closed, it is then opened for the different other activities. That land must be reused, and so this, for this purpose, it should be free from any kind of risk. So to make it risk free, there must be a proper lining or sheeting, and that cover is actually final cover designing is actually important to reduce the negative impact on the environment. And then finally it will be used for any other purpose which is uh, not so much exposed to the human health. So here is another sectional view of sanitary landfill. Here you can observe what kind of layout is required. So first of all, there is a lining, and this landfill liner system is again important, and it must be designed. And normally geotextile membranes are used for this purpose, because they are quite good in lining. uh, a natural liner is a clay, as we talked in the previous lectures, but that clay is not uh, sufficient enough. So we need some better source of protection to prevent the leakage and movement of leachate to the soil. And this infiltration is most commonly controlled by a landfill liner system. That landfill liner system normally consisting of the geotextile membranes. Then we need to design the cell sizes based on the nature of the waste which is going to be disposed in each cell. and and then this every cell will be covered on daily basis, and this cover is again you can observe it is about 15 to 30 centimeters. That means it is about half to 1 feet in thickness. So it is only important to keep the impact of other wastes separate. So then there is a lift. You can observe that first lift, then cell height, another lift, and then up to this final lift. There is a height more than 15 to 25 recommended, and then stability of slope is important, and then the slope is about 3 to 1 in ratio. So an intermediate curve is about 6 inches. Again, it's about 15 centimeters as in the other shown in the other cells. So this is something about the sectional view of the sanitary landfill. Here you can see how it is going to be placed. The waste is going to be placed, and you can see development and completion of a solid waste landfill, excavation and installation of landfill liners, and then this lining and monitoring facility is provided. That stockpile excavated material is again kept for the future use. It will be used for the cover, and leachate collection pipes are being installed. Then you can see here the replacement of solid waste in the landfill. It is being added and then it is being covered. Here it is development and completion of the landfill, and completed landfill will be looking like this, in which the final cover has been provided and the landscaping has also been done to reduce the negative impact. And then long-term operation of the leachate and gas collection and monitoring will be available, so that the monitoring is continuously done. So what are the concerns with the landfilling of the solid waste? So normally uncontrolled release and discharge of landfill gases, for example methane and hydrogen sulfide, odors and explosion, greenhouse effect in atmosphere, uncontrolled release of leachate which is in liquid form. It is again as a result of the chemical reaction, and contamination of groundwater and surface water is an important factor which is to be considered. Breeding and harboring of disease vectors is also an important factor to be considered. Release of trace gases arising from the hazardous materials is also important factor to be considered. So goal for the design and operation of a modern landfill is to eliminate or minimize the impact associated with these concerns as explained above. We have three types of landfills. So class 1 is about secured landfill, and it is for the hazardous waste. Then we have monofills, which is designated waste, combustion way ash or asbestos. And then sanitary landfill, which is commingled waste, mixed waste coming from different sources. So these are the three different categories: 1, 2 and 3. In 3 only MSW, municipal solid waste, not only but also non-hazardous industrial waste and sludge from water and wastewater treatment plants are accepted. Solid content should be greater than 51%. So least controlled landfill is supposed to look like this. It should have a retaining wall, it should have a fencing, and then the plastic tip, rubber tip, iron tip, glass and ceramic, concrete. All these are the materials available there. Landslide protection should be there, subsidence protection should be there. Landslide protection is due to the movement of the layers, underground layers, while subsidence protection is due to the collapsing due to the overloading of the structure. Controlled landfill is for again non-hazardous waste, and in this case we are having retaining wall trench, we are having effluent control system, we are having leachate control, and then we have uh, ventilation systems, seepage control, and subsidence protection, landslide protection. And then we have finally the M1 category, and first category, and that is the strictly controlled landfill, secured landfill, and it needs a more and better protection. It is constituting of hazardous waste altogether. It must have a proper fencing, it must having a minimum reduced infiltration, and so it must be kept free from any kind of infiltration coming in the form of rain and storm water protection. And And every section must be properly separated from the other cell, so as to reduce the interaction, and that interaction may cause some negative impact and result in chemical activity, so it must be reduced. So a polder is a low lying tract of land enclosed by embankments, so there must be barriers. Those barriers are actually used to separate the different sections of the landfill. So preparation of site for landfill. Again, the drainage is modified to route any run off away from the intended landfill area. Access roads and weighing facilities are constructed and fences are installed. Landfill bottom and subsurface sites are excavated and prepared. Excavations are carried out over time rather than preparing the entire landfill bottom at once. Uh, so the excavations are only as per the requirement. Then the geomembrane is used liner as a liner. Leachate collection and extraction facilities are placed within the uh, top within or top of the liners. These are the preparation of the site for landfill. You can see here landfill bottom is being prepared. Normally it is explaining the excavation process, but it is again based on our designing how much in depth we can go, and this depth is again related with the availability of water table beneath the ground surface. Then we have another geomembrane liner being installed at the bottom. Then we are placing the leachate collection system. You can see the drain pipes are being installed. Then this is the final shape of the landfill ready for the disposal. Placement of waste. So normally we have different cells, uh, and waste deposited by transfer vehicles are spread out in 50 to 60 centimeter layers. So this is about 2 feet depth of the layers. And then there is a compaction is again a part of lining. Successive lift are placed on top of one of another until the final design grade is reached. That grade is actually the level, surface level up to which we are going to fill it. And again, with the passage of time, and the waste is going to settle down, and it is going to again we have some space to be refilled. So refilling until the design grade is possible. Then this is the placement of waste. You can observe the waste is coming, and then it is being spread, compacted and covered with soil. With the final design grade is reached, landfill is capped with a final cover and then landscaped. So what kind of reactions are taking place in landfill? So it is again important because these are actually producing leachate, and these are actually producing the gases which are being released into the environment. So normally biological reactions which are due to the organic materials in municipal solid waste leads to evolution of landfill gases and leachate. Physical reactions like diffusion of gases, emission of landfill gases to the surrounding environment, movement of leachate within landfill into underlying soils, settlement caused by consolidation and decomposition of the landfill material. Once the landfill material is decomposed, it becomes soft. The bonding between them is loosened, so that finally settles down due to its own weight, and that settlement is one of the reasons of the displacement. So that displacement is going to affect the upper lying layers of the waste. Those upper lying layers are going to then settle down, and this settlement is actually going to affect our designed parameters and designed setup. And in those design setups we are talking about the cover, daily cover, then final cover, and uh, uh, about the drains for the leachate collection, and about the gas collection. All these are being affected due to this settlement. So this is very important to understand what kind of reactions are going to take place, how the decomposition is going to take place, and what is the possibility. And based on these guidelines and these analysis, we are going to plan our uh, filling of the landfill process. Reactions occurring in landfills, so chemical reactions are again the same, like dissolution, suspension of landfill material, evaporation, vaporization, absorption, dehalogenation, decomposition, oxidation, reduction reactions. Now, concerns with landfill, we have already talked about the concerns. It is about the uncontrolled release of gas and wastewater, and then some compaction is also important. Then breeding and harboring of disease vectors is also a risk factor. So all these things are being considered. Then there are some methods of landfilling, and most commonly there are excavated cell trench method, canine depression method, area method, offshore and inshore reclamation. These are the methods which are possible for the landfill design. So while designing a landfill, we must first of all investigate the site, what kind of site is available for us, and then we must have a site characterization, and that site characterization will include the level of groundwater. It must include the geological formations, the stability of the soil. All these things are important to understand before we plan and finalize the site for the landfilling. So it all depends upon the topography of that land, what kind of landfilling method is going to be adopted. So this is again a final uh, diagram. It is quite obvious, we have already explained it in the previous slides. So this is the landfilling methods. Excavation method, so it is ideally suited to areas where an adequate depth of cover is available and water table is not near to the surface. So soil excavation, the excavated soil is used for the cover as well. So and are typically square, and trenches are long ditches. So this is how we are going to have the excavated cell. And some other methods like area method, it is used when the terrain is unsuitable for excavation, and high groundwater conditions uh, necessitate the use of this type. So in this type we are going to have the barriers on the sides, and we are going to develop it on the surface. So cover material must be hauled by a truck and or earth moving, so which is going to make the barrier. Compost produced can be used as intermediate cover materials. Then another important way is the depression method. It is, if there is already an available, the topography is allowing us to have a depression in the topography, and we can use that naturally available topography for the landfill purpose. Then we are going to adopt this method, and the control of surface drainage is critical factor in this case, because it must follow the natural slope and natural flow, and then it is started from the top of the head of the this depression, moving towards its face. So it will help in the accumulation of water on the back end of the landfill. So these are some of the methods which can be used based on the topography and available site. And after the site investigation and site characterization, the engineers, landfill engineers, can properly finalize which method is most suitable in these circumstances. So then we have, again, this is the final slide, landfills siting considerations, including the haul distance. Haul distance is actually uh, the traveling of the transport of the waste from the uh, collection points to the landfill. Then location restrictions, available land area, site access, soil conditions and topography, climatologic conditions, surface water, hydrology, geologic and hydrogeologic conditions, local environmental conditions, and ultimate use of the completed landfill. So how finally we will be dealing with the completed landfills? As I explained, as I gave one example of the Tokyo landfill. After its completion, it has been converted into an airport. So we must know what is the final purpose of the final usage of the landfill, and then on that basis we will be considering the landfill site. So this was about the landfill, its designing, its layout, its planning and operations, and what control measures are required. So it was a brief introduction to all these points. In the next lecture we will be talking about the non-aqueous phase liquids, what's their behavior in soil and groundwater, how differently they are going to behave. There are two types, light and dense, how they differently behave. It is our next lecture. So thank you very much for today's lecture. Thank you.